Nuclear power. I am hardly what you consider an expert, but I have covered it somewhat in my physics course. So I'm going to try and explain what happened at the Fukushima plant. Essentially, it was a very unfortunate fluke. After the Chernobyl disaster, certain safeguards were created as standard, such as a very thick shielding around the reactors to stop radioactive materials escaping in the case of a disaster. But there were a series of events leading up to the meltdown that made that a gesture that was quite in vain, basically. I'm going to use the aid of a crappy diagram here. The standard safeguard in this kind of situation would be that the fuel rods that contain the fissile material would have been lowered into the control rods. Now, the control rods are basically inhibitors for the chain reaction. They would absorb the particles that keep the reaction going and stopping any more power from being generated. But this mechanism that would lower it jammed, or something. That's an assumption. But for whatever reason, the fuel rods remained exposed, so they could keep reacting. This meant that the water coolant all around it, I'm not going to draw it because it'd make it all look messy, but the water coolant then evaporated and somehow underwent some kind of lysis, which means that the water vapor was split up into its constituent molecules, both oxygen and hydrogen. And oxygen and hydrogen are very combustible. So the inevitable explosion cracked the reactor casing, allowing bad stuff to be expelled. Now, that didn't happen in the other plants because obviously the control rods managed to do their job and stop the reaction, but this happening is highly unlikely, especially now, because Fukushima showed us that it's obviously not a perfect system, so engineers will invariably be sent out to think of better safeguards. But also, this isn't a reason why we should fear nuclear power, since it is currently the most efficient green power source we have. It is a common misconception that nuclear power is an infinite resource, though. As it stands, the fission reaction of getting power, we have a very limited supply of fissionable materials that we can use in these plants. I mean, the amount of fissionable uranium, because it's a certain isotope that we need, it's a very rare isotope of uranium that we use in comparison to the rest of the uranium isotopes. Basically, the only real way of having a infinite good green power source is the holy grail of power generation being fusion power, and that would basically just use their air. We'd just whack two molecules of hydrogen, or heavy hydrogen known as deuterium, together, and the energy created by fusing two molecules is far bigger than the energy created by splitting a molecule. So that would give us infinite green energy to use. But that's a long way off. And for now, the safest power source we have is nuclear fission, and there's no real reason to fear it, especially since most of us do not live in an area where such extreme earthquakes or natural disasters are likely to happen. and thus cripple our plants. So there's nothing we have to worry about, essentially. And that's about it.